Good morning, good afternoon, and good evening, regardless of where you are in the world. Thank you all so much for joining today's webinar. I'm really excited to tell you about the new approach that VMware is taking to firewalling, which we call the service-defined firewall. My name's Alex Berger, and I'm with the product marketing team in VMware's networking and security business unit. And we believe that this innovation, this service-defined firewall, really solves one of the most persistent and important problems that our customers face today. Namely, how do you protect your applications and your data when an attacker, or a malicious insider for that matter, has already breached your perimeter defenses and gained access to your internal network? In this webinar, I'll explain the stark difference between the perimeter security problem and the internal security problem. We'll also discuss how the nature of modern applications has really made solving that internal security problem a lot more challenging. Then I'm going to go ahead and introduce you to the capabilities of our service-defined firewall that enable it to change the way that the internal security problem and internal security in general can be approached and solved for. And then finally, everybody's favorite part, I'll show you how the solution protects an application against a real attack. So we'll actually demo the capabilities and show you what this thing looks like in practice. But before we get there, I want to kick things off by mentioning that the service-defined firewall is part of a mature platform that unifies security and networking capabilities for the entire stack, from layer 2 all the way up through layer 7. And to date, this platform has been adopted by over 10,000 customers, including some of the largest environments in the world. It's scalable, it's effective, and it's real. And that's a good thing. It's a good thing that it's real too, because we've all seen this slide before, right? This is the slide that tells everybody that we're still losing the security battle. I know most likely everybody on the call has heard about the Target breach, right? Where an attacker was able to compromise Target's HVAC vendor, of all things, in order to gain access to Target's internal network eventually, which was, of course, the real Target, no pun intended. But that was all the way back in 2013 already, right? That was 5 years ago. And the real question we should all be asking ourselves is, what has been done to prevent that from happening again? How have we firmed up our internal network security to prevent a situation like that from happening again? Now, I included these particular statistics on this slide to illustrate a very specific point. The way we're approaching internal network security is fundamentally flawed. That first statistic shows that attackers are dwelling in the network for nearly 3 months on average, giving them the time they need to cause real damage. And this damage is to the tune of $3.86 million on average per attack. Now, they're not getting in because of some brilliant technological feat, right? In fact, they're stealing your users' legitimate credentials and walking right in through the front door. Stolen credentials was the #1 most common attack type in 2018. And to make matters worse, all of this is still happening despite the fact that on average, an organization has 75 different security products that they deploy and manage in their environments. So it's not a matter of we're not spending money. It's not a matter of we don't have products in place to try and prevent this. It's not a matter of we're not trying. It comes back to the fact that the way that we're approaching this is fundamentally flawed. Let's dig into that a little bit deeper, particularly the products that we have at our disposal to solve this problem. Why can't I just use my perimeter firewall to secure my internal network? Why won't that work? Well, the fact is that the problem of securing the perimeter is a very different problem than that of securing the internal network. It's apples and oranges. And to illustrate this difference, I'd like to use an analogy. So imagine that you are a TSA security scanner at the airport. And not only that, but you're a TSA agent at the airport during the holidays, right? Just to make it more, even harder, right? And of course, during the holidays, you get this crush of people coming through, and it's your job to figure out friend from foe. How do you handle that? Well, of course, you'd probably do a cursory screening of each person that comes through with your eyes, right? To see if you see anything suspicious, a bulge in the pocket, or anything else that might stand out to you as marking somebody as potentially a threat. You'll, of course, check their ID to make sure that they are who they say they are. And then you'll put their bags through the X-ray machine to see if you find anything nefarious inside. And of course, you'll use a metal detector to actually scan the people themselves for anything dangerous. Now, these tactics are akin to what a perimeter firewall uses to filter traffic from an unlimited number of unknown hosts, right? Sandboxing does an eye check of behavior for anything suspicious. URL classification, signature analysis, these types of tactics are like checking whether or not somebody's name is on a no-fly list or looking inside their luggage for obvious threats. And since a perimeter firewall has no real context about the hosts where traffic originates from, these are the tactics that it has to rely on, much like the TSA agent. Now, let's contrast this with the internal network security problem. When it comes to securing applications inside the network, the situation is much more akin to securing your family or your home. You know your family and your home, just like you know your applications in your environment. Doing things like installing metal detectors and X-ray machines throughout your house, mandating ID checks every time your son comes down to breakfast, and running background checks on your wife when she leaves for work in the morning, these aren't the right approaches for securing your family. Instead, you protect your family by understanding their typical behaviors, their daily patterns, what you expect them to do. If you know that your daughter is a bit of a bookworm, she's a vegetarian, she likes cartoons, and so on and so forth, you've established a pattern of her known good behavior. If all of a sudden you hear a noise in your office at 2 a.m., and you go in there and you find your daughter rummaging through your desk, reading your papers and speaking in Russian, of course, on the phone, you'd probably determine that something is up, because that's pretty deviant behavior or different behavior from that known good pattern that you normally observe. And ultimately, this is the core difference between the perimeter security problem and the internal security problem. It all boils down to this difference in what you're able to know. At the perimeter, it's impossible to really determine what known good behavior will look like. But inside your network, known good behavior should really be the guiding force for how we define and enforce security for our applications. Now, unfortunately, establishing the known good behavior of applications has gotten increasingly difficult. When all applications lived in a monolithic stack, it was easier to essentially know how those applications should behave and what to expect from them. But to be perfectly honest, with the adoption of virtualization came the distribution of applications across tiers consisting of multiple servers, which in turn meant more behaviors to keep track of as the app grew and changed over time. And of course, this trend of distribution and decentralization has really been catapulted forward by containerization and the creation of microservices. Modern applications are really a network of distributed services now, consisting of many different workloads that can be hosted virtually anywhere. They've also become increasingly ephemeral, allowing for agility and speed from a development perspective, but also making it much harder from a security perspective. And quite honestly, most environments contain some or all of these application architectures, adding to the complexity of the entire situation. And as we all know, complexity is ultimately the biggest enemy of security. Now, this multitude of problems is why the biggest challenge in security has really shifted from keeping bad guys out of the environment to preventing bad guys from moving laterally inside the network, especially given the complexity of modern applications and services. Now, at this point, I'm sure it's becoming clear that while perimeter firewalls are great at protecting the perimeter of the environment, as the name would suggest, they aren't going to solve the internal security problem. First of all, architecturally, perimeter firewalls are boxes and appliances that network traffic has to literally pass through in order to be filtered. Now, you wouldn't want your family having to go out of their way to continually pass through a metal detector. The same applies for your network traffic. You don't want to have to hairpin your internal network traffic through a box or an appliance every time you move a packet east-west in your environment. And frankly, even if you wanted to do that, it would be operationally and financially infeasible to route all of your east-west traffic through a perimeter firewall. And frankly, that's the reason that very few people do it. We see time and again in our customers' environments, very few controls put in place to mitigate lateral movement and control east-west traffic. Now, perimeter firewalls also rely on an inflexible policy structure. To go back to our family analogy for a second, in the winter, your son wears shoes, and because it's cold out, right, obviously, and you ask him to take off those shoes when he comes into the house. But in the summer, your son probably runs around barefoot more often, and asking him to take off those shoes every time he comes inside doesn't really make any sense at that point. The point is, when changes in the environment and your applications take place, which, as we talked about before, is becoming increasingly frequent, you need security policies that are flexible and won't break in the face of those changes. Now, finally, because perimeter firewalls are designed to filter traffic coming from unknown hosts, they lack any real application context. As we talked about earlier, applications are more than just protocols at this point. They're distributed networks of services. And just like a TSA agent lacks all of the context about each of the people that they have to scan, perimeter firewalls can't get the full picture of your applications. It comes down to the difference between guessing versus knowing. Okay, so then what is needed to secure the internal network? Well, first, and frankly most importantly, we need distributed controls for distributed applications. And it turns out that the virtualization layer provides a perfect place for us to insert security controls in order to deliver this distributed protection. By inserting security controls directly into the hypervisor, we make security intrinsic to the environment and to the infrastructure. Now, other vendors will attempt to provide distributed controls by using agents deployed on endpoints. The problem with that is that agents are vulnerable, right? They live and reside in the attack surface itself. And I'll actually show in the demo later on just how easy it is to disable and get around an agent-based approach. They also require some level of operational overhead to run, maintain, etc. The fact that we've made security intrinsic means that our controls are always on and that they're isolated from attack. You can't simply turn them off. It also allows us to bind policies to the services and workloads that those policies protect. And this will become increasingly important as the presentation goes on, but essentially, binding security controls to workloads and services means that as those workloads and services move and change over the course of their life cycle, their security policies move and change with them. Another advantage of building security controls into the hypervisor is that we effectively turn every workload in the environment into its own firewall. This means that we actually have massive amounts of throughput capacity at our disposal. In fact, as the environment grows and more hosts are added to your environment, the more throughput capacity that you get. So effectively, your internal firewall actually scales with your environment over time. Now, finally, a distributed architecture also means that we can filter traffic between two VMs on the same host, two containers that share the same port, or even two native cloud workloads on the same VPC or VNet. Every packet flowing in your environment can be inspected and filtered. And more importantly, it can be done without the need to hairpin traffic, which means there's also an improvement to your network performance itself. Okay, so we need an intrinsic distributed architecture. What else do we need? Well, we need security intelligence that is specifically tuned for internal network security. Of course, that means that at the network level, we need fully stateful L7 deep packet inspection. But we also need to make sure that when we're doing things like IPS and IDS, the signatures that we're looking for are those that we would expect to see from a threat that is already inside the network. So these are things that would look like a recon, like a reconnaissance phase of the attack, or lateral movement, or obfuscation, or even exfiltration strategies or stages of the cyber kill chain. And so you can see we've got some of those examples listed here. Things like like communication out to command and control center servers, or mapping activities, things like that. We want to make sure that when we talk about security intelligence from an internal perspective, we're focused on the stages of the cyber kill chain that we see inside the network. Now, going hand in hand with this and really kind of rounding out this intelligence. Whoop, come on, slide. Come on. Sorry, there we go. All right. So rounding out this security intelligence is this ability to do deep application behavioral analysis. We need to know and make sure we really know our family, right? This means getting a complete understanding of the application's topology, which includes the workloads and services that make up that app. And then going a level deeper, going inside each of those workloads and understanding what processes we expect to see running them and what network traffic we expect to see those processes generating. Now, all of this behavior constitutes what we call the known good behavior of the application. Just like you establish a pattern of behavior for your daughter that constitutes known good, like we talked about earlier. But we don't want to stop there. We also need to verify that what we think known good behavior looks like really is known good behavior. So for instance, if your daughter is the first daughter you've never had girls before, and now you have a daughter, you might ask your friends who already have daughters whether or not your daughter's behavior is normal or not. Or frankly, maybe you'd ask Google for that matter. I don't really know, to be quite honest. I'm not a parent yet. Well, the point is the same goes for application behavior. It's incredibly important to verify behavior so that you don't accidentally classify malicious behavior that's already present in your environment as good or normal. And we'll talk a little bit more later about how we do this in the service-defined firewall. Okay, so once we establish an understanding of known good application behavior, we can automatically recommend and generate the security policies that we need to secure the app on day 0 all the way through day N. And one of the best ways to do this and to make this seamless is to integrate the internal firewall directly into the CI/CD pipeline. This way, whenever developers create new workloads and services, those changes are actually automatically captured by the firewall, and the policies are provisioned accordingly. Now, as applications change over time, these policies need to be able to adapt to maintain our security posture, of course, without impeding progress and innovation. Similarly, if a system administrator is doing maintenance and needs to move a workload off of a host, the security policy for that workload should move with the workload seamlessly. And finally, policies shouldn't only adapt when good behavior changes. What about threats? Right? They also need to adapt in the face of a discovered threat. And the internal firewall needs to be able to automatically configure and enforce policies that can do things like quarantine a workload that's been compromised. We can even do this based on threat detection feeds from third-party tools, like an antivirus or something like that. If you have antivirus already deployed in your environment, and you have the internal firewall as well, our service-defined firewall, antivirus, when it detects a threat, can actually configure policies in the service-defined firewall to quarantine the workload where that threat was detected, creating a seamless security posture all the way through. Okay, so last but not least, let's talk about flexibility and consistency. Policies, so the policies that we're generating have to be both flexible and consistent, and consistently enforced in particular. We need to be able to create policies based on virtually anything. And the best way to do this is by using groups and tagging so that you can essentially create group definitions based on custom tags, things like user identities, workload attributes, and more, right? And this gives you the flexibility you need. For instance, we have lots of customers that create a group for their PCI workloads. And as new workloads are created as part of the application development process, those workloads are automatically tagged with their PCI policies. And that makes sure that those workloads automatically inherit the security policies they need to keep them PCI compliant. Now, you can also import attributes from your CMDB if you so choose. And equally important to this flexibility, this dynamicism, is the ability to enforce policies everywhere that workloads live. Now, that's whether we're talking about VMs, containers, bare metal servers, regardless of where they're hosted. It could be in a private cloud or public clouds. The ability to orchestrate consistent policy across heterogeneous infrastructures is crucial, not just for enforcing a strong security posture, but also making sure that managing that security posture is easy and effective. Now, the VMware service-defined firewall is the answer to this challenge of securing your internal network. And the solution itself brings together two of our products, VMware NSX and VMware App Defense, in order to align and bind security controls to the services that make up your applications. By establishing the known good behavior of an application at both the compute and the network level, the service-defined firewall automatically is able to discover and generate the security policies needed to lock down the app to a least privileged or a zero trust, if you so choose, model. And over time, the solution adapts these policies as the app changes. Now, I promised earlier that I would talk a little bit more about how we verify that known good behavior really is known good. And that's where the App Verification Cloud comes into play. The App Verification Cloud uses a combination of human knowledge and machine learning to build models of known good application behavior. Now, these models are compiled from a combination of things. First is the observed application behavior across VMware's expansive footprint. And we combine that observable behavior with reputational feeds. Now, what's really powerful about the App Verification Cloud is the unique way in which it applies machine learning. Most security vendors use machine learning to build models of threat behavior that are then used to identify future threat behavior. And the problem with this approach is that threat behavior is unbounded, right? It's constantly changing, continually morphing, and it'll continue to do that forever, right? Attackers will always change up their tactics, and new exploits will always become available over time. And it's really hard to, you're essentially playing a game of catch up forever. For those of you who know a little bit about machine learning, you probably know that you get the best outcomes out of a machine learning algorithm when you can train that algorithm on massive data sets of highly repeatable scenarios. Well, there are lots of examples of applications behaving normally in the world. And it turns out that VMware is ideally positioned to observe this normal behavior day in and day out. So that's what we train our algorithms on. We train them on what good behavior looks like. And then we use that to help verify that the way your applications are behaving is good, right? We've seen this application deployed a number of times. We see it behaving in such a way And we're looking at your version of that application and comparing it and saying, yep, your application is behaving the way we see this, or I should say your application's behavior is consistent with the way we see this application functioning across a wide spectrum. So that's how we verify that known good behavior in your environment really is known good behavior. And we're not just capturing an already infected system's behavior and scoring that as good. We'll see how that manifests in the products in just a few seconds. But before we get to that, I want to sum this all up. And really what it comes down to is that it's time for a paradigm shift in the way that internal security is done. And that's exactly why we built the service-defined firewall. With this solution, we shift the defender mindset from a hyper-focus on threats and attacks to a focus on reducing the attack surface of applications inside the network perimeter. We're overcoming the inherent lack of awareness about what's running in your environment and providing you with a deep understanding of your application's topology and the behavior. And that deep understanding is critical in order to offer the right kind of protection. And we're enabling customers to move away from the numerous bolted-on security products that make up most environments and really move to this model of embracing security that's built in and an intrinsic part of the infrastructure and applications that reside in your environments. So it's really all about this paradigm shift. But enough slideware. Let's move on to everybody's favorite part. I want to actually show you what the service-defined firewall looks like in action. Now, the demo that I've prepared for you today showcases an attack against a basic 3-tier web application. And first, I'll attack the app without the service-defined firewall solution in place. So the only, you'll see in just a minute, but the only protection that this application has is some basic antivirus running on all the servers. Now, after I show you how I can compromise this app, I'll then go back and I'll layer in the solution components, namely NSX and App Defense. And I'll show you how we can start to lock down our application systematically. We'll start by enforcing microsegmentation, network security policies for the entire app. And then we'll move a step deeper and we'll actually do process level whitelisting and enforcement at the process level of the application to further lock it down. And it'll become evident why both sides, both parts of the spectrum are really important. So let's go ahead and get to this. Here is our 3-tier application. And again, this is a web application. You can see that the website is running on Drupal and it's back-ended by a MySQL database. So as I mentioned before, the only defense that this application has is some basic AV running on all of these, on all 3 of these servers. Okay, so I'm going to go ahead and put my attacker hat on. So let me go ahead and share my screen here. And of course, as the attacker, I don't know anything about how this application is architected, what it's running on, any of the stuff I just showed you, right? So the first thing I'm going to do as the attacker is I'm going to go ahead and I'm going to do a little reconnaissance. And I'm going to run a quick script from my attacker machine here to determine how the content of the app is being delivered. And as you can see here, I've found that it's actually Drupal 8 that is serving up this content. So now using a free utility called Searchsploit, I'm going to look for known vulnerability exploit combinations that I can use to specifically target Drupal 8. And sure enough, I've found a few. Now all that's left is for me to go ahead and use the exploit. And essentially what I'm going to do is I'm going to run a quick script to initiate a reverse TCP connection, which allows me to ultimately gain access to the app server. Once I have shell access on this server, I have the ability to execute code directly on the machine. And the first thing I'm going to do using the same exploit code is I'm going to immediately disable the antivirus that's running on this machine. Again, agent-based technologies, those agents are hosted in the attack surface and they make it very easy to turn off. So with the AV disabled, I go ahead and I run Mimikatz in order to dump the user accounts, hash, and credentials on the app server. These credentials are really important, right? Because once I have these credentials, I can use them to run a pass the hash attack in order to gain access to the database server of this application. Once I've taken control of the database server, I can go ahead and log into it. And now I can go ahead and upload, install, and run some crypto mining software. Because ultimately, what I want to do is start making some money. Okay, so let me go back to my other console here for a second. And let's recap what just happened. So here's my application. I am the attacker attacking from my Kali Linux box out there in the environment. And the first thing I do is come in right through the front door. One of the main reasons I was able to successfully compromise this app was because I was able to exploit the app server over port 8443, a port that's open by necessity so that the app can communicate with the internet. So like I said, I came right in through the front door. And once I did that, I was able to establish that reverse TCP connection, which gave me access to the app tier of this of the box. So now I established my connection and I got shell on that machine, which allowed me to disable the AV agent that was running there. And with that, I got free reign, right? Once the AV was off, I was able to dump those credentials and then use those credentials to pass the hash from the app tier to the DB tier. Once I passed the hash, I was able to take full control of the DB tier. And from there, I was able to, there's my pass the hash. I was able to install my cryptojacking software and start exfiltrating my Bitcoin. So all set, when it's all said and done, it was relatively easy for me to take complete control of this entire application from the app tier all the way to the DB tier and use it to my advantage. What I'm going to do now is I'm going to start layering in the components of the service-defined firewall. And I'm going to start locking down the app. We're going to start with some micro-segmentation policies so that, as you'll see, it'll make it harder for me to be able to move so easily laterally throughout the application. And we're also going to turn on app defense in alert mode, so it's going to start watching everything I'm doing. So again, I'm going to switch gears here, and I'm going to pull up my, my screen. There we go. Allow. Okay. So the first thing we're going to do is we're going to start by enabling app defense. And because this application is hosted in a vSphere environment, enabling and turning on app defense is actually really easy. I can do it with the click of a button. So you can see me doing that here. And with app defense running, we immediately start to see application behaviors show up in my console. These behaviors are really just the processes running on each of the workloads that make up my application. And because app defense is embedded directly into the vSphere hypervisor, app defense is collecting these behaviors without the use of additional agents deployed on the VMs. And as you saw in the last attack, it was really easy for me to compromise and disable that agent-based AV software. For each process, app defense is running the behavior through the app verification cloud, which provides a general reputation score for the binary. You can see that designated by the green icon to the left of the screen there. And as we touched on earlier, the app verification cloud is designed to verify that the behavior of a given application is in fact known good behavior. And this analysis, of course, informs whether a given application's behavior looks normal or not. So as I start to establish this picture of known good behavior for the app, we can visualize the entire application's topology. And from within this visualization, we can actually drill into all the different dependencies of the different tiers and understand what normal traffic looks like for the app. This visibility is going to be instrumental in determining what process level behavior and network behavior, for that matter, should or should not be allowed when we start creating policies. And you can see here that this app tier normally communicates to several public IP destinations as part of its execution. We can also drill into the individual processes and see the actual command line arguments that the process is executed with, the hashes associated with a given process, and of course, the network connections that the process is making. As I said before, this deep understanding of what talks to what will become really important when we're ready to create our network security or microsegmentation policies. And as you can see here, what we're looking at now is actually the distributed firewall table in NSX. And what we're looking at for this application, you can see there's nothing configured. There's been no microsegmentation of this application so far. And I want to go ahead and change that. So I'm going to go ahead and flip the system into protected mode. And when I do this, you can see I have the opportunity to create NSX firewall policies as soon as I do that. Now that I've flipped the application into protected mode, I'm basically telling the system to create network and process level rules that will ensure that only the known good behavior is allowed to take place. In the case of the network, these rules are microsegmentation policies. So now when I go back into the NSX Distributed Firewall table, I can see that I've got all my microsegmentation policies automatically generated for me. And this is now enforcing a zero trust model for this entire application. In particular, you'll notice that we have a rule here that restricts communication between the app server and the DB server to only port 3306. And the reason I highlight this is simply because this will become important during my next attack on the application when I kick off the next attack. So here we go. I'm going to go ahead and kick off the same attack that I did before. And as you'll see, I can still get shell on the app tier, and I can still even disable the AV that's running on that server pretty easily, right? It's the exact same attack that I tried last time, but this time, when I try to pass the hash using the stolen credentials from that app tier, I'm blocked. And that's what you just saw, that the microsegmentation policy between the app and DB tier have prevented me from moving laterally. So instead, what I'm going to do is I notice that I can still manipulate the app server by actually going down to the operating system and running code on that server. So this time, what I'm going to do is I'm going to kick off some ransomware to cover my tracks and bring down the entire app tier. So there you go. I was still able to cause some damage. And for those of you who weren't keeping up with the scripting, we can go ahead and review what exactly I just did, right? So let me stop sharing my screen and slip back over to my slides here. Okay, so this time around, first of all, one thing I want to note is that we now have microsegmentation policies in place, right? Those firewall icons between the different tiers of my application. And you'll notice that we have little green icons, the eye icon, on each of our endpoints now, because App Defense is running in detect mode or watch mode. So we've established our microsegmentation policies. We've got App Defense running. Now, one thing to note that although the icons make it look like App Defense has agents sitting on each of these workloads or each of these tiers, I want to be clear that that's poor icon placement. Both NSX and App Defense do not rely on agents in order to do this, even though the icons kind of make it look like they're there. So anyway, I've got my microseg policies in place. I've still been able to gain access, of course, because we didn't prevent the app tier from communicating out over port 8443. So I still came right in through the front door. And the attack unfolds similarly to the way it did the first time, right? My reverse TCP connection. And then I come back in over port 53 and I get shell on the app tier. I disable the AV agent. Now here's where the catch comes in. This time, when I try to pass the hash, I'm blocked by my microsegmentation policy. And you all saw that in the demo. So instead, what do? I reestablish a connection and I use some ransomware to bring down the entire app tier and cover my tracks so that nobody knows what I was up to and what I was doing. So I was still able to cause some damage. And the reason why I think it's important to kind of show this phase of the attack is because no attack in reality is going to leverage a single threat vector, right? Attacker is going to use multiple vectors in order to compromise you. So you really need to be, it's not enough to just address network security or endpoint security. You really need to bring all of these components together when you're talking about internal security. And let's go ahead, I'm going to go ahead and share my screen again as we get ready for the next wave of attack here, so that you can see the damage that I was able to cause. So let's go ahead and run our video here. So now you can see I'm trying to bring my system back online after my ransomware attack. And in the end, my microsegmentation policy worked effectively, but obviously I was still able to cause some damage. So how do we prevent this from happening, right? Well, now I'm going to go back into my App Defense console, and I'm going to go ahead and enable App Defense in block mode. So before we were running in protect mode, that was able, we were able to establish our microseg policies, but now we're going to go ahead and block. In the last attack that I ran, App Defense was sitting in watch mode, and it was seeing everything I was doing. Here are all the alerts that App Defense was generating from all of the commands that I was executing throughout my attack. But it wasn't doing anything about it, right? It was just seeing everything I was doing and logging it and alerting the SOC to the fact that I was in there. But it wasn't showing or wasn't doing anything. And as you can see here, I'm going in and showing the Petya executable that I ran when I installed the ransomware. This time when I kick off the attack, not only are my microseg policies going to be in place, but now App Defense is actually going to prevent any deviant process from known good behavior from running. So as you can see, this time when I try to get shell on the app tier, my command fails. I'm not able to do it. When I try to disable the AV, that command is blocked as well. Frankly, that's it. At this point, my entire attack dies right on the vine. So for completeness sake, let's go ahead and review what just happened. Let me go back over to my other console here. And obviously, this last attack is relatively unexciting, right? Because here I am. You can see App Defense is now moved from an eye icon to a lock icon because we're in block mode. And again, I come in through the front door and I get access, or I try to get access to the app tier, but my executable is denied, right? I can't get shell on that app tier. I can't disable the AV agent. And really, I can't do anything. I'm pretty much stuck. I can pack up my stuff and pretty much go home. And that's really all there is to it. That was me trying to run the AV disable request, and that was blocked as well. So there you go. The entire attack, both a code execution attack and a lateral movement attack, mitigated by the service-defined firewall. So yeah, to sum it all up, what you just saw was the service-defined firewall, NSX and App Defense, working together to first establish the known good behavior of my application, and then use that understanding to generate microsegmentation policies on the network and process whitelisting policies on each of the workloads that make up the app in order to mitigate a multifaceted attack, right? That was leveraging multiple vectors. And really, it's as simple as that. I mean, that's what the service-defined firewall is all about, giving you the intrinsic security that you need to shrink the attackable service of your applications as much as possible. Let's see here. So with that, I want to thank everybody for attending this session and this webinar. Hopefully you were able to see how the service-defined firewall from VMware can help you reduce the attack surface of your applications within the network perimeter of your environment. And if you're looking for more information, obviously in today's webinar, you saw how the solution was able to mitigate a couple different types of attack vectors, but we've actually put this solution through its paces. There's a great report on VMware.com from one of our third-party vendor that we worked with to vet the service-defined firewall. It's called the Veritin Effectiveness Report. You can find it on the service-defined firewall page on VMware.com. And what's really great about this report is it actually shows how the service-defined firewall can mitigate a number of different attack vectors. And basically what we did was we took the solution and we ran it against a number of different attacks, all of which correspond to vectors and techniques as defined by the MITRE ATT&CK framework. So I highly recommend, if you're interested in learning more about the solution and what it can do, go check out that report. There's also some other great literature on the site that will give you a little bit more of an idea of how this solution works, what types of threats it can stop, etc. And of course, if you're interested in having a more detailed conversation, reach out to your VMware sales rep and ask them about the service-defined firewall. Hopefully everybody enjoyed today's presentation. I really enjoyed giving it. We will take a few questions, I believe, in the Q&A chat. So feel free to answer or enter any questions you might have. And I'll talk to you hopefully all in the future. Thanks, everybody.